The next type of elimination problem that I am going to give you is called a cryptarithmetic problem. And what a cryptarithmetic problem is when you basically code numbers in terms of letters and you add them together. And each letter represents a digit 0 through 9, and it cannot be repeated. All right, so here we have a really goofy story, and we'll give you an example of a cryptarithmetic problem. Gordon and Pearl lived on a farm in Concordia, Kansas, where their father Emil and their mother Olive. One day Gordon asked his father, "Dad, what happened to that cat I used to have?" Pearl, overhearing this, said, "Yeah, I used to have a horse. Where is she?" Emil replied, "Gordon's tomcat and Pearl's old nag were not much use. I traded them for my new goat." Olive then said, "Hey, that sounds like a good cryptarithmetic problem. Let's see if we can solve it." She wrote down G tom plus P nag equals E goat. Each letter stands for a different digit 0 through 9. No two letters stand for the same digit. Determine which digit each letter represents. And there are two clues. G equals 5 and A is an odd number. Okay, so here I wrote down the cryptarithmetic problem. And I'm going to first write down what we know. So actually the first thing I'm going to do is I'm going to write down all the digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. We're going to cross them off as we use them. We know that G equals 5, and we know that A is odd, so it can equal 1, 3, 5, 7, or 9. Well, wherever there's a G, I'm going to put a 5 there, so I'm going to put a 5 here, I'm going to put a 5 here, I'm going to put a 5 here. And I'm going to cross off things. So I'm going to cross off this 5. We'll use a different color, we'll use green, because we know that A cannot equal 5, and we utilize the 5 up here. Done. Alright, that's all we can use that clue for. So what we're going to have to start doing is we're going to have to start manipulating things. Alright, so I've got a 4-digit number plus another 4-digit number equals a 5-digit number. And so basically what we're going to do is we need to figure out what is E. And to be sure of what E can be, we are going to find our extremes. Find extremes. So what I mean by that is I'm going to find the biggest number that could possibly be an answer. So if I make a 4-digit number with all 9s, and I add another 4-digit number with all 9s, those are the two biggest numbers that I can add together that are 4 digits. And so I add them together and I get an answer of 19,998. So what that's telling me is that E must equal 1. So I'm going to write down a little statement. E equals 1 because the biggest solution has a 1 in that spot. Okay, so E equals 1. So I'm going to put a 1 here, and I'm going to cross off the 1. Done. So we found E. Alright, so the next thing I'm going to do is I'm going to look at a certain part of the problem. I'm going to look at the G plus P and equals 15. So I'm going to put a step 3 right here. We know that G, which is 5, plus P, and then it must equal 15. Because the only way we're going to get 15 is P equals 10, right? Well, P can't equal 10, so P must equal something smaller than 10. So plus a remainder.
I know.
Well, let's say our remainder up here is a 1, because that's usually what they are. And so then we're going to say, okay, 5 plus p plus 1 equals 15. Well, if I do some solving, 5 plus 9 plus 1 equals 15, so p equals 9. So we're going to put a 9 in for p. And so we're going to cross off that, and then we've got our p is taken care of. Okay, and so now let's look at another part of the problem. Let's write down some other stuff. Let's look at the t, n, and o. Actually, let's look at the o and the a first. I'm going to look at those two parts. I'm going to make some sense of them. So I'm going to go right here so we can see some stuff. I'm going to use cursive O. Plus a equals a. Oh, so I need something plus a equals itself. So that's telling me that O must equal 0. And that's because 0 plus a is equal to a. So we're going to let O equal 0. Okay, so now that I know that O is 0, then A still could be 3 or 7. It can't be 9 because we said that 9 was used up. So it could be 3 or 7. All right, now I'm going to look at the T and the N. So I'm going to go to step 5 here. T plus N. Well, T plus N can't equal 0, so it has to equal 10. So now what I'm going to do is I'm going to think of two numbers that add up to 10. Well, let's just hold off on that. Let's write something else that we know. All right. Let's look at m plus g plus t.
Why are you making a video?
Okay, so let's look at something else we know. So I'm going to go to step 6 here. Let's go a different color. We also know that m plus 5 equals t. Well, t cannot be greater than 10 or 9 because we can't have any remainders because 0 plus a equals a. And it has, so m plus 5 must be less than 9. And also m plus 5, well, it can't be less than 5, so it must be greater than 5. So let's write down all the possibilities for m. M can equal 1, 2, or 3. Because t can't be 9. Okay, so did we use any of those letters or those numbers? Well, we used a 1 already. So let's cross off the 1 because we used it. We didn't use a 2 or a 3. So then step 7, notice I didn't even use step 5. Step 7, we're going to use a guess and check. Guess and check. And I'm just going to write down the stuff. So I'm going to say, hey, let's let m equal 2. So if m equals 2, then let's put a 2 here, and a 2 plus 5 is 7. So then t equals 7. Okay, if t equals 7, we put it over here under there. Then n equals 3 because we have to have it equal to 10. So n equals 3. And so then we got to see what a is left with. But this doesn't work. Doesn't work. And the reason it doesn't work is because we need a to equal 3 or 7. And so if we use both of them up, there's no room for a. Okay, so now put a cross off that. Let's try let m equal 3. Okay, so let's erase what we did here. So there's a 2, a 3, a 7, 7. Okay, so let's go back up. I said m equals 3. Let me rewrite it so that we can see it. M equals 3. So if we put m equals 3, then t will equal 8. Okay, if t equals 8, then n will equal 2. Okay, so let's cross off our numbers that we used. So we used a 3 for the m. We used a 2 and an 8. So that leaves us with a has to be 7. And a equals 7. And that's our problem. Okay, so now when you go through these, no, we don't use each digit sometimes. That's okay. And you don't have to write complete sentences for me. That's okay if you don't do that. All I want to know is, what did you do first? You know, you wrote in your stuff. What did you do second? And why did you do it? What did you do third? What did you do fourth? I understand that I have a t plus n equals 10 here that we didn't use, but write it down anyway because you know that that has to be true. What did you do next? And just try to organize your information the best you can so that I can follow along so I understand your thought process. That's what I'm looking for in the write-ups. Okay, so that is a crypto arithmetic problem. Thank you.